We're in a race for the human race. We're in a race for the human race. To save our planet that we can't replace. No other Earth is there in outer space. Give Mom a break, for goodness sake. I'm gonna give much more than I take. I'm not defined by what I buy, but what's inside my heart and my mind. I'm not defined by what I can buy, but what's inside my big heart and mind. Not much we need, say goodbye to greed. Life is in great peril and it's time to take heed. Nurture all the flowers with the birds and the bees. Trees upon the land and the fish in the sea. No need for all those goods and plastic packaging. The earth is sort of blue cause she wants to be green. The SUV sucks up too much energy. Imagine travel that's petroleum free. Water that's clean and air that we can all breathe. With solar panels on our roofs and our streets. No offshore oil, no ocean spoil. The future of our world is up to you and to me. The keepers and the flowers and the birds and the bees. Trees upon the mountain and the fish in the sea. Meaningless consumption just pollutes everything. The earth is so blue cause she wants to be green.
Today is a special day. It's planet Earth's birthday. Try and guess how many candles you'd need for its birthday cake. 100,000? 10 million? Nope. No fewer than 4,540,000,000 candles. Try blowing all them out at once. But that's how old our Earth is. 4,540,000,000 years old. So how can we imagine such a huge number? Suppose you stuck all the candles from the Earth's birthday cake next to one another in a line. The line of candles would be 45,000 kilometers long, so long it could easily go all around the Earth. But although the Earth is incredibly old, it hasn't always been here. Even the Sun hasn't always been here. Instead, there was a huge and extremely cold nebula swirling around these parts. So, what do you need to cook such a nebula? The recipe's actually quite simple. To make one portion of nebula, you need a big bottle of fresh hydrogen, a smaller bottle of mellow helium, and a pinch of interstellar dust. Mix everything together, put it in the freezer, cool to a temperature of -270 degrees Celsius, and tip out into space. And when you make billions of such portions, your cosmic nebula will be ready. But is it really possible that our solar system formed from something like this? Well, believe it or not, it is. A little shake was all it took to get things moving. The nebula began shrinking and thickening until it turned into a flat, rotating disk. And while doing so, it got warm enough to start shining. Because a huge glowing ball of hot gas, a star, formed in the nebula's center. It might surprise you to hear that you actually know this star very well indeed. We call it the Sun, and it still shines in our sky today. But the Sun wasn't alone for long. It soon found it had company. Smaller bodies that were made from the remnants of the nebula. Planets, asteroids, and comets. How were they made? Well, it was actually quite simple. Grains of cosmic dust collided and stuck to each other to form small stones. The stones clustered together to form boulders as big as cities, called asteroids. And the accumulated asteroids stuck together to form large planets, The formation of comets was similar, except that in the case of comets, the grains of dust were replaced by crystals of ice. All these bodies have been orbiting the Sun for 4.5 billion years. Together, they form our solar system, our place in the universe. Did you know that stars and planets still form in space today? It's absolutely true. Astronomers know of many such places where this is happening. They even call them stellar nurseries. And you can see one of them in the sky with the naked eye. It's in the winter sky, in the Orion constellation, approximately here. To the naked eye, it resembles a fuzzy cloud. That's why it's called the Great Orion Nebula. But in photos taken by large astronomical telescopes, it looks completely different, like a giant cloud of glowing gas with many bright spots. And these are young stars, which might already be orbited by planets. You know what? Let's take a quick look at the best our solar system has to offer. That way we'll only see the most interesting bits of it. And what better place to start than the Sun? The surface temperature of our star is 5,500 degrees Celsius, but this is nothing compared to the temperature beneath it. A thermometer would measure more than 15 million degrees Celsius down there, if your thermometer hadn't been vaporized, of course. And there's one more exceptional thing about the Sun. It's hot enough to shine dazzlingly bright, unlike all other bodies in the solar system, which you can only see because they're lit by the Sun. So if the Sun and stars went out, it would be pitch black in here. We'd better turn them on again. After all, the most interesting things in the world of planets are yet to come. So, do you know how many planets there are orbiting the Sun? Are there A, 8, B, 10, or C, 19? And the correct answer is A. There are a total of 8 planets in the solar system. If we flew away from the Sun, we would first pass Mercury, then Venus, our own planet Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Do you see how all the planets orbit the Sun? To get a better idea of how they do so, we've also highlighted their orbits. But don't forget that while it takes a year for the Earth to orbit the Sun, for Neptune, for example, it takes as much as 165 years. You might think that all the planets are the same size. Well, they're definitely not. One of them is truly a giant. Do you know what the biggest planet in the solar system is? Is it A, Mercury, B, Earth, or C, Jupiter? This time, the correct answer is C. The biggest planet in the solar system is Jupiter. Its diameter is 11 times greater than that of the Earth. When we adjust the size of the other planets to match the current size of Jupiter, there's no doubt about it. You see, There are 4 small and 4 big planets in the solar system. The small planets are Mercury, Venus, Earth, and Mars, while Jupiter, Saturn, Uranus, and Neptune make up the big ones. But none of the planets can compete in size with the Sun. Even giant Jupiter looks rather inconspicuous next to it. After all, we could fit almost 1,000 planets the size of Jupiter into the Sun. Do you like scaring yourself? Well, try to imagine you're suddenly crazy about maths and physics. Do you want to scare yourself even more? Well, imagine you've become a teacher. No, you know what? A university professor of mathematics, physics, and astronomy. Fortunately, you're doing some really interesting research. You're searching for a planet that could be colonized in future by human beings. Which do you think is the best candidate? Which planet is most like the Earth? Is it A, Venus, B, Mars, or C, Uranus? The correct answer is B, which means Mars. What? You think that orange Mars is far from being Earth-like? Come on, it is round, and it does have a solid surface. What's that you say? That's not enough? Well, what about the conspicuous white area around the planet's North Pole? After all, we have something like that on Earth as well. If you're thinking of the frozen Arctic or Antarctica, you're on the right track, because you can find ice caps near the poles of Mars too. And that's not all. On this neighboring planet, you can also find lofty mountains and deep canyons. You still see Mars as being far from Earth-like? All right, what about now? Better? This is what Mars probably looked like several billion years ago, when it had a lot of liquid water on its surface, and also a dense atmosphere and a lot of active volcanoes, which made it quite hot. But over time, the volcanic activity ceased, its atmosphere disappeared, and Mars cooled down. And the water vanished as well. It soaked into the ground and froze, or vaporized and escaped into space. The only water you can find here now is the ice near the poles of Mars. But evidence for the presence of liquid water on Mars long ago can still be found on the planet's surface today. We know this thanks to the space probes that have observed Mars from space and landed on its surface. The most obvious clues are probably the empty, dried-up riverbeds. When seen from space, they look like giant branched channels cut deep into the ground. They stand out especially when we highlight the heights of the Martian ground with different colors. The places with depressions or indentations, which could be channels carved by water, are colored purple and blue. On the other hand, the various hills, mountains, and volcanoes are colored yellow, red, and white. The colored Martian surface now closely resembles the mouth of a giant river flowing into a sea or lake. Unfortunately, the reality is a bit less fantastic. If you really landed on Mars, you would only find a dead, rocky desert, occasionally decorated with a sand dune, and also a terrible chill of 70 degrees below zero, because Mars's orbit is already quite far from the Sun. However, Mars has broken the records twice. It's home to the largest volcano and also the deepest canyon in the solar system. We're now flying to the first record holder, the volcano Olympus Mons. It rises to a height of 21 kilometers and looks like a huge blister. But even mountains can't rival this monstrous pyramid of solidified lava. The terrestrial Mount Everest would look like a younger sibling next to it, because it's almost 3 times smaller. The outline of Olympus Mons stands out especially when it's lit by the slanting rays of the rising or setting sun, and the volcano casts long shadows. But now we're heading for another record, Valles Marineris. A complicated system of canyons of barely imaginable proportions. In fact, it's a huge crack in the Martian crust, 4,000 kilometers long and 7 kilometers deep. Valles Marineris is 9 times longer and 4 times deeper than the Grand Canyon in the United States. The sunsets on the bottom of Valles Marineris must be amazing. So, which planet shall we head for now? Or do you think we didn't stay long enough on Mars to warm up enough before we go on? Don't worry, soon you'll be really hot. Do you know which planet has the hottest surface? Is it A, Mercury, B, Venus, or C, Earth? If you chose B, which is Venus, you've answered correctly. But I admit it was a trick question. The closest planet to the Sun is not Venus, but Mercury. So shouldn't Mercury be the hottest? Surprisingly not, and in a minute you'll see why. Although it does occur to me now that you won't actually see much, because Venus is obscured by very thick, opaque yellowish clouds. And there's nothing to suggest that hiding deep beneath them is a hellish world. So, if you want to see it, we must strip the planet of its atmosphere. Ladies and gentlemen, here it comes for your viewing pleasure, the naked Venus. But be careful with her, she's pretty hot. The temperature of the surface of Venus reaches a record 460 degrees Celsius. Under such conditions, some metals, like lead or zinc, start to melt. Venus's rocky surface is so hot that it even glows red at night, like an old hot stove. But Venus is associated with high temperatures. It was once a volcanic kingdom, way back in the past, and even today some of its extinct volcanoes can rival the highest mountains on Earth. It seems there isn't a place untouched by volcanoes on Venus. Actually, its entire surface is covered by a massive layer of solidified lava. In many places you can even see channels several thousand kilometers long that spilled lava over their surroundings. Another striking view is that of the areas where lava made its way to Venus's surface. There are giant cracks and bulges which vaguely resemble ticks and spiders. So why is Venus so hot? Well, that's due to its atmosphere that was shaped by the volcanoes. It consists of unbreathable carbon dioxide, and you can even find droplets of caustic sulfuric acid in the clouds. But the important thing is that the dense atmosphere is a bit like a lid on a pot. It doesn't allow the heat brought to Venus by the sun's rays to escape back into space, so the surface of Venus gets permanently overheated. But once we've come to this part of the solar system, we must also visit Mercury, the smallest planet and the one closest to the Sun. The grey stone face of Mercury is marked by a number of circular depressions called craters. They were formed a long time ago by asteroids or comets crashing into our planet. Such craters can also be found on the surface of our Moon. The most conspicuous are the craters with long, bright rays of ejected material extending outward from their centers. Mercury's rather careworn appearance is also intensified by the various scratches, breaks, and cracks in its crust. You probably won't be surprised to learn that Mercury is quite hot. But at the same time, it's also terribly cold. It depends which side you look at. It's hot everywhere on the sunlit side. The temperature of the surface here reaches over 400 degrees Celsius. On the other hand, the night side, facing away from the sun, is unbelievably cold, almost minus 200 degrees Celsius. Imagine a similar situation here on Earth. After sunset, everything on the planet, including us, would freeze solid. So how does it happen that the hot surface of Mercury cools down so quickly with nightfall and the temperature drops by a record 600 degrees Celsius? It's because Mercury, unlike Earth or Venus, doesn't have any atmosphere to prevent heat from escaping into space. Which is, in fact, really cold. Actually, we haven't measured a temperature lower than that of interplanetary space. Anyway, hot or cold, Mercury is a rather boring and numb planet. So let's move on and cheer ourselves up somewhere really busy. Let's visit the planet with the most moons. Do you know where we're going? Which planet has the most moons? Is it A, Saturn, B, Uranus, or C, Neptune? And the correct answer is A. Saturn has the most moons. Imagine that apart from its famous rings, Saturn has more than 60 larger moons and over 150 smaller ones. We can easily visualize the largest of Saturn's moons by displaying their orbits. Pretty messy, isn't it? The Earth with just one moon, albeit a big one, just can't compete. But at least it's something. For example, Mercury and Venus don't have any moons at all, and Mars is not much better off either. It has just 2 moons, but of a dwarf size. It's hard to say which of Saturn's moons is the most interesting. Maybe Titan, a giant among the moons that is even bigger than Mercury. Titan also holds an important record. It's the only moon with a dense atmosphere. It's deep orange and its rain contains methane, a substance similar to the liquefied gas in lighters. The frozen Enceladus is also worth mentioning, as now and then there are ice geysers exploding on its surface. And we should not forget the two-tone Iapetus, or the sponge-like Hyperion. However, Saturn is unique for something else. Its rings. It's not that other planets don't have rings. We can also find them spinning round Jupiter, Uranus and Neptune, but we hardly notice them. On the contrary, you can't miss Saturn's halo. No wonder. After all, the rings have a diameter of 300,000 kilometers. But at the same time, they're also extremely thin. If Saturn shrank to the size of a hot air balloon, its rings would be thinner than a sheet of paper. You could easily cut yourself on them. Would you like to look inside the rings? No problem, but be careful. Do you see that? The rings consist of nothing more than a huge number of ice particles. But while the smallest ones could only be seen with a magnifying glass, the largest are the size of a 2-story house. Anyway, they whiz past you at the speed of 60,000 kilometers per hour. Does that make you feel dizzy? Then you won't like what's to come. Soon we're going to enter the eye of the biggest storm in the solar system. Do you know where to find it? Is it A, on Jupiter, B, on Uranus, or C, on Neptune? The correct answer is A. The biggest planet, Jupiter, takes pride in having the biggest storm. As with Saturn, the journey to Jupiter is lined with dozens of large and small moons. The 2 most notable are Io and Europa, something like fire and water. Grey Europa is covered with an icy crust, beneath which there's an ocean of liquid water and who knows, maybe even simple life forms. But we can only imagine, of course. On the contrary, the yellow-orange Io is decorated with a number of active volcanoes, spewing out sulfur and toxic gases. But enough of them. Now let's focus on Jupiter itself. This striped world would certainly be a meteorologist's paradise, because they could never get their forecasts wrong here. And what would they say? It'll be another cloudy day today with strong gusts of wind and intense thunderstorms accompanied by lightning. After all, the wild weather is the only thing we can observe on Jupiter. All we can see are colourful clouds everywhere arranged in several conspicuous cloud bands. In addition to that, there are violent storms that constantly rage in the planet's atmosphere, which would destroy any building on Earth. Do you see that big reddish stain on the planet's southern hemisphere? That's the biggest storm in the solar system. It's called the Great Red Spot, and it is truly great, about twice the size of the Earth. In fact, it's a giant atmospheric vortex, and all of Earth's hurricanes would be humbled by it. But the most interesting thing is hidden under the clouds. Actually, there's something missing. Jupiter has no solid surface. No kidding. If you dived deep into Jupiter's atmosphere, the gas around you would gradually grow denser and denser, finally turning into a strange liquid, resembling a very thick syrup. And you would find the same on Saturn, Uranus, and Neptune. Together with Jupiter, these planets can be compared to giant balls of compressed gas. Would you like to have a piece of Jupiter or Saturn at home? All you need to do is buy a balloon filled with hydrogen or helium. These are the gases that both planets consist of. And what about Uranus and Neptune? We could say they're like Jupiter and Saturn's cousins. Although they look different, they do in fact have the same composition. They're also gaseous planets with no solid surface and with gales and storms roaring in their atmospheres. They have large families of moons, and if you take a closer look, you'll even find inconspicuous dark rings. Did you know that not far from here, between the orbits of Mars and Jupiter, there's a danger zone that you'd better avoid? Do you have any idea what you could collide with there? Is it A, a rocket, B, a black hole, or C, an asteroid? If you answered C, you're right. There are millions of asteroids wandering throughout the area between the orbits of Mars and Jupiter. Have a look. We can highlight them. Each white point is one asteroid. And what does an average asteroid look like? Like a potato-shaped piece of rock with a diameter of several kilometers. But we can also find asteroids as big as cities. Well, here we have one. Asteroids can have various names. They're named after famous scientists and artists, or after various interesting places. Imagination has no limits. But asteroids can be quite dangerous. From time to time, they may cross the paths of planets and collide with them. If such a heavily built asteroid hit the Earth, it would easily destroy an area as large as Europe. We're reminded of these collisions by the craters that can be seen, for example, on Mercury. But worst of all is that we can also encounter large families of asteroids in other parts of the solar system. There are simply billions of asteroids. Actually, not just billions, billions of billions. I don't know about you, but I'm fed up with all these planets and asteroids. You know what? Let's go to the very edge of the solar system. The journey to this dark world goes past Uranus and Neptune. But we're not stopping. I'm only willing to slow down a bit. There. We've come to the end of the line. There's nothing to suggest that we've really come to the gloomy world of comets. But the darkness around us hides billions of sleeping comet nuclei. Shortly, we'll get even closer to one of them. Sure, it's nothing special yet, but hold on. When such a frozen comet nucleus sets out on its journey to the center of the solar system, things start to happen. As the comet nucleus approaches the Sun, its surface heats up and vaporizes. An ordinary comet is nothing but ice mixed with dark dust, something like a big dirty snowball with a diameter of up to several kilometers. Then the escaping water vapor and dust shroud the comet nucleus and create its stunning tail. If such a comet gets close enough to the Earth, with a bit of luck, we can observe it with the naked eye. And if the comet dust hits the Earth, it conjures up an unusual show in the sky. People say they're falling stars. The romantic ones even make a secret wish. But in fact, what they're watching are meteors, little grains of comet dust that fly quickly through the Earth's atmosphere. So, hurry up, make a wish. What? You wished this show would end? Okay, have it your way.
We're in a race for the human race. We're in a race for the human race. To save our planet that we can't replace. No other Earth is there in outer space. Give Mom a break, for goodness sake. I'm gonna give much more than I take. I'm not defined by what I buy, but what's inside my heart and my mind. I'm not defined by what I can buy, but what's inside my big heart and mind. Not much we need, say goodbye to greed. Life is in great peril and it's time to take heed. Nurture all the flowers with the buds and the bees. Trees upon the land and the fish in the sea. No need for all those goods and plastic packaging. The earth is sort of blue cause she wants to be green. The SUV sucks up too much energy. Imagine travel that's petroleum free. Water that's clean and air that we can all breathe. With solar panels on our roofs and our streets. No offshore oil, no ocean spoil.